Hi, my name is Michael Radushkin, and this is my lab report for Lab 1. The video will go as follows. A brief introduction, followed by the experiment, followed by the results of the experiment, followed by code modeling the experiment, and finally ending with a discussion. The main purpose of this lab is to find how much excess charge there is on a prepared piece of tape, which we'll later discover is 1.86 times 10 to the negative 8 coulombs. Some of the models and physical principles that will be explored throughout the lab include vector forces, which is simply a magnitude and direction, Coulomb's law, which describes how two charged objects interact with each other and provide equal but opposite forces to each other, as shown in the model in the bottom left-hand corner, forces due to gravity, which describes the forces and interactions between two objects that have mass, and finally, negative, neutral, and positively charged objects. And now onto the actual experiment. The system of the experiment is the floating part of tape B as shown in the left. The surroundings in the experiment include tape A, which provides a charge force to the system, and the Earth, which provides a gravitational force to the system. The initial conditions of the experiment include tape B and tape A being positively charged, which will be discussed in the next slide. The floating tape B section being 0.2 meters, and the floating tape section's mass being 2 times 10 to the negative 3 kilograms. The only force acting on floating tape B in the initial conditions is gravity. In the actual experiment, we slowly bring tape A up below tape B. Once we see that tape B is visibly beginning to float upwards, we stop and record the distance between tape A and tape B. We know that tape A and tape B are positively charged because they were both prepared the same way, and we notice that when they were brought up to each other, they started to repel each other, indicating that they both have some similar charge. And when one was brought up to a neutrally charged book, it was weakly attracted to it, again indicating that it has some sort of charge. To conclusively determine what charge it has, we brought up the tape to a negatively charged pen, and it was strongly attracted to it, meaning that the U-tape had a positive charge. Before we go to the results, we're going to answer some questions. If there's no change in momentum, we know that there's also no change in velocity. And if there's no change in velocity, we know that there's zero acceleration and thus zero force. The only vertical forces on the floating portion of tape B include the gravitational force due to the Earth and the electric force due to tape A. And we know that their magnitudes are equal to each other, as there is no momentum in tape B, meaning that there is no net force in tape B, meaning that the opposite forces have to cancel each other out. And in order to find the force of gravitation and thus also the electric force, we simply have to find the mass and multiply it by the gravitational constant. And now onto the results. Using the discussion in the previous slide, we now know that the magnitude of the gravitational force and the magnitude of the electric force is 1.96 times 10 to the negative 3 newtons. From the experiment, we found out that the separation distance where tape B begins to float is 0.04 meters. Using these values and the electric force equation, we found that the charge is 1.867 times 10 to the negative 8 coulombs. Using this value, we can find the number of electrons that are deficient on tape B, as tape B is positively charged and thus has more positively charged protons than electrons. And we find that there is 1.167 times 10 to the 11 electrons that are deficient on tape B. With the amount of electrons that are deficient calculated, and using the assumption that each atom takes up the same perfectly sized square shape, and assuming that the tape is 1 atom thick, we could determine the amount of deficient electrons per atom, which we compute as 3.241 times 10 to the negative 7 electrons per atom. And now onto the code that supports the experiment. To the left, there is a blue sphere that represents tape A and the red sphere that represents tape B, with the green arrow indicating the force created by tape A and the orange arrow indicating the gravitational force on tape B. And as we can see, the calculated charge of tape B and tape A is also 1.86 times 10 to the negative 8 coulombs as we calculated previously. And so what assumptions and approximations did we use? We did not have to ignore air resistance, as tape B was simply floating and not moving. We did treat the long tape as though it was a point charge, as shown in the model, and we did assume that each U-tape had about the same amount of charge and evenly distributed. And now some post-lab questions to conclude the presentation. Some possible errors in the experiment include the handling the tape, which could have caused a loss of positive charge on both tape A and tape B, as discussed below. Also, we could have potentially introduced a force by air on the tape by breathing on it during the experiment. If the electrons have positive charge and protons have negative charge, all observations would have remained the same, and there simply would have been a non-visible swap of charges.